This is the measure whether they these together as measure. Let's do question 24. You have a table tennis ball, a ping pong ball, falls vertically through A. So this is air. Figure 11 shows a variation of kinetic energy. So you have a graph of energy versus height. So you got h naught, this is h, and then it's sort of flattened up at here, and they label this Ek. Shows a variation of kinetic energy Ek, so this is actually kinetic energy of the ball with distance h fallen. The ball reaches the ground after falling through a distance h naught. So over here, basically, h naught is where it hits the ground. On figure 11, draw a line to show the variation of h of the gravitational potential energy EP of the ball. Okay, this is Ek. So this graph is actual energy, not kinetic energy graph. So you need to show the EP in this graph, gravitational potential energy, and h equal to h naught, the potential energy is 0. So it says over here, your EP is equal to 0. So your 1 point here. Problem is you need to find the other points. So using Pogote, energy source is equal to the energy used. So the object is here before it hits the ground. So this is h naught and this is h. What actually happens here? At the top here, so this is the source. It is at rest, it's falling, so it only has gravitational potential energy. When it falls, it only has kinetic energy. That is the case when there is no air resistance. Since we've done a lot of questions relating to this, you already know what we need here. We need the work done against air resistance. As the object moves through the A, you're going to be literally losing some energy to the A. So this will be your work done against A. If you see this, you will notice that EGP cannot be equal to Ek. So we cannot begin your Ek here. We know we have to supply work done against A. That means in order to supply energy, your energy source has to be higher. So EGP at the beginning is at a higher location. After that, what shape does it have? In order to know what shape it has, you have to look at the equation. So EGP equal to mgh. Wait a minute. This is a E against H graph, which is y equal to mx plus c, where your c here is 0, your EGP is your y for energy, your x here is your h. Therefore, you're locating, and then your gradient will be your weight. So it is a straight line. Okay, if you see here, the gradient is actually positive, but you have a negative gradient here. Why? That is because here is your maximum EGP, here is your literally EGP equal to 0. Therefore, it's a straight line down, and this is the correct graph is actually a delta EGP graph equal to minus mgh. Why? Because we are losing gravitational energy. So that's why it goes down. Okay, I hope you understand this part of the video. If not, please duplicate this video.